Hi everyone, welcome to lesson 4.4 on solving compound inequalities. Let's first begin with our math cap, which is compound inequality, which is an inequality consisting of two inequalities joined by and or or. And here are two examples. If joined by and, you will see usually your variable right in the middle between two expressions. And if joined by or, you'll see the word or. When you have an inequality with and, this is an intersection. So when you graph it, you want to make sure that your graph shows the solution set which would fit both inequalities. Now, if it is a graph of or, then this is a union, which means that the graph consists of points that are part of either graph. So again, if you have and, your solution must fit both inequalities. If it is joined by or, your solution must fit either. First, let's practice writing inequalities and graphing compound inequalities from a sentence. So here we have all real numbers are greater than -2 and less than 3. And you want to make sure that you identify whether you see and or or. So x is less than 3. So when you graph an intersection, remember you graph the first one. So x is greater than -2, open circle to the right. If you graph the second one, x has to be less than 3, open circle to the left. And looking at the intersection, you want to see what points would fit both inequalities. And that would be the points that are between here and here. So when you graph your final compound inequality, you will have between -2 and 3 as part of the solution set for this compound inequality. Now go ahead and do number 2 on your own, pause the video, and play it once you have your work done. For number 2, I have x is less than 0 or x is greater than or equal to 2. I graph the first inequality, and I shade to the left, open circle. I graph the second, shade to the right, close circle. And because this is or, that means you have a union. So you want to graph all the points that fit either inequality. So you would graph both inequalities, whether they intersect or not, onto your final graph. We now transition real quick to translating a word problem to a compound inequality. So here we have, and you don't have to write this in your notes, just read. At an auction, the lowest bid for an autographed trading card is $20, and the highest bid is $54. Write and graph a compound inequality. So first thing you want to recognize is whether you need and or. Because it says and, you know that this will be an intersection. So when you write your inequality, the lowest bid is $20, therefore the bids must be greater than or equal to 20. And the highest bid is 54, so it cannot exceed $54. To write this together as an intersection, you would just write x in the middle, and x is less than or equal to 54, but greater than or equal to 20. And when you graph this number line, include your numbers that are part of the expression, and recognize whether you need an open or closed circle, shade in between, since that is the only solution set that would include points for both inequalities. And now we are on to the fun part, which is the solving process. So solving for and is different from solving for or, and you'll see why in just a moment. Let's practice the first one together, and then you'll do the second one on your own. So for our first compound inequality with and, we have 2 is less than x plus 5, which is less than 9. Now to solve a compound inequality with and, whatever you do to one expression, you must do to the others. So if I want to isolate x, because I'm trying to figure out what my solution set is, I'm going to subtract 5, not from only this expression, but from every expression to keep this balanced. So 2 minus 5 is negative 3. I've isolated my x, and 9 minus 5 is 4. And on to the graphing. X must be less than 4, but greater than negative 3. Open circles, and this would be the solution set that would contain all the points for both inequalities. And as far as your check goes, you want to look at your number line. So what number in my number line do I have that is part of the solution set? Easy one would be 0. So I'm going to use 0 as my check, the number that I will substitute to my original inequality. So 2 is less than 0 plus 5, which is less than 9. And you just want to check if it's true. And 2 is less than 5, and 5 is less than 9. So that is correct. Now it's your turn, and I want you to solve this compound inequality. We have negative 5 is less than or equal to negative x minus 3, and that is less than or equal to 2. So take a moment to solve this, pause the video, and remember, key point here, which I want you to write in this section of the notes, whatever you do to one expression, perform on all the other expressions as well. So keep it balanced. Okay, hopefully you've done the work, and now let's review the steps together. So step 1, I added 3 to every expression to start isolating my x. That gives me negative 2 here and positive 5 there. Now I notice that I have negative x in the middle, and I want just x. So I divide everything by negative 1, or you can multiply everything by negative 1. And when I do that, negative 2 divided by negative 1 is 2. 5 divided by negative 1 is negative 5. And because I performed an operation with a negative, I have to reverse each symbol. And when I reverse each symbol, my solution becomes x is greater than or equal to negative 5, and it's also less than or equal to 2. So it's kind of written backwards, and it's okay if you write negative 5 first here, and then x, and then 2. But make sure, again, your symbols reverse. In graphing, since x has to be greater than or equal to negative 5 and less than or equal to 2, my solution set is the set of points in between those two numbers. We are now on to our last part of our notes, and this is solving compound inequalities with OR. Now the difference between AND versus OR is that for OR compound inequalities, you want to solve each inequality separately. And let me show you how that works. So here I have 2x plus 3 is less than 9, or 3x minus 6 is greater than 12. Let me work with the first one. So subtract 3 from both sides, you'll get 2x is less than 6. Divide each side by 2, and x is less than 3. Solve the second inequality, add 6 to both sides, and I'll have 3x is greater than 18. Oops, that doesn't look like an x. 18. Divide both sides by 3, you'll get x is greater than 6. And because this is an OR compound inequality, when you graph your solution set, you graph with the understanding that the set of points for x is less than 3 and the set of points for x is greater than 6 would both work because OR is a union. So you would graph all solution sets that work for either. So if I were to graph x is less than 3 and x is greater than 6, you notice that because I don't need to worry about overlapping when I graph my final compound inequality, you would just graph both solution sets of both inequalities. You do not need to worry about a overlap or an intersection. So now let me give you a practice problem of your own. Notice I'm missing a open circle here. And again, pause the video to do the work first and play once you're done. So here is your practice problem. We have 3h plus 1 is less than negative 5, or 2h minus 5 is greater than 7. Go ahead and pause the video, do the work, play once you are ready to compare. Okay, so take some time to compare your work with my work. I subtracted 1 from both sides of the first inequality, got 3h is less than negative 6, divided both sides by 3, h is less than negative 2. And for the second inequality, I got h is greater than 6. When I graph my compound inequality, because this is a union, I graph the solution set for both inequalities without having to worry about an intersection or overlap. So because Thanksgiving is around the corner, my random parts in the video that I want to use to make sure that you are watching, paying attention, is to bring up Thanksgiving. So looking at this picture, and also from your experiences, if you do celebrate it, what are 3 words that come to your mind when you think of Thanksgiving? Write those 3 words in the appropriate section in the form. After you've done that, you are then going to choose to read one of 4 articles or watch a video that is from the Native American or American Indian perspective. And after you've read that article or watched that video, I want you to respond by writing your thoughts or questions that were raised after you've read that article or watched that video. And again, write your response in the appropriate section in the form. And finally, I just want to remind all of you again that we have our first homework quiz on Thursday. Yay! And for the homework quiz, make sure you come prepared by bringing in your assignments from 4.1, 4.2, 4.3, the intersections and unions handout, and in addition, also your homework quiz that you will complete in class. So see you Thursday. If you have any questions, please write them in the form. Bye-bye.